Good evening, all of you. Yesterday, I told you about the three types of methods that we come across when we go for time series. That is semi-average freehand method or graphic method, semi-averages method, moving averages method, and the last method is nothing but method of least squares. This method of least squares is completely a mathematical method. Okay, in order to find out the trend values, in order to find out the trend estimates, we have to take into account the least squares method. This method is most widely used one. It is a mathematical method, and with its help, a trend line is fitted to the data in such a manner that the following two conditions are to be satisfied. When we are using this least squares method, okay, we have to observe that whether this method is satisfying two conditions or not. What are the two conditions? Okay, sum of differences of computed values to the original values of y must be 0. That is, sigma y minus yc is equal to 0. That is the first condition that you must come across when you are going for this least squares method. Okay, this is the first condition that we come across. Okay, the second condition is sum of differences of computed y values from the actual y values must be the least. That is the second condition. When you satisfy these two conditions, we can say that the method of least squares can be applied to find out the trend values of trend values of any time of not only one thing, but it will take into account any time, whether it may be a base year or a current year, they must satisfy this. So that is nothing but method of least squares. The method of least squares may be used either to fit a straight line trend or a parabolic trend. Okay, if you want to go for straight line trend or a parabolic trend, this is the second type of trend that we come across. And this parabolic trend, it may come across, it may not come across. Okay, so we can say that this parabolic trend is nothing but a secondary trend. First, we must get the trend values. Okay, of a straight line. When you go for a straight line, what are the trend values that we come across? That is the primary thing. And the parabolic trend is nothing but the secondary for this straight line trend. The straight line trend is represented by the equation yc is equal to a plus bx. Here, already in the previous classes, I told you that a, b are constants, and we will call them as parameters of the straight line. A gives us the, A gives us the magnitude or the way of difference, and B gives us the direction of the trend. So these are the two things. When you are going for least squares method, okay, we have to take into account two variables, that is variable x and variable y. When you take into account variable x and variable y, okay, one variable is independent and the other variable will be dependent. That is compulsory. Okay, in the two variables, one must be independent and the other must be dependent. Okay, sometimes x will act as an independent variable when X is acting as an independent variable, Y will become the dependent variable. And Y, when it is acting as an independent variable, automatically Y will become the dependent variable. Okay, basing upon this only, the regression analysis, regression equations, they'll come into picture. There also you'll come across the method of least squares. And here also you'll come across method of least squares. Here, when you take into account this portion, it will help us to find out the trend values in the future period of time, how the trend values will come when you take one variable as independent and one variable as dependent. Generally speaking, we'll take into account Y as dependent variable and X as independent variable. Okay, we'll take Y value as dependent variable and X value as independent variable. So when you are taking like this, automatically you will come across a trend line. And when you go for the graphical method and when you want to draw a straight line, there also one thing you have to remember, that Y is equal to mx plus c. So there also Y is nothing but a dependent one, whereas X is a independent one. Okay, you may ask me, sir, whether we'll come across the straight lines. Okay, whether we come across straight lines, two straight lines. Yes, you'll come across two straight lines. And these two straight lines, when by taking your this thing, which variable you are taking as independent and which variable you are taking as dependent, basing upon that, you will come across straight lines. Suppose if you take Y variable as dependent and X variable as independent, you will come across a straight line. Okay, because the formula is Y is equal to A plus BX. And this A and B, we will call them as parameters, and they are constant. They won't change. So basing upon the constants and basing upon the parameters, okay, the Y values, they will change and we'll get the computed values. And after getting the computed values, we have to take into account whether the two conditions, whatever we have studied, that is sigma Y minus YC is equal to 0. That is the first condition. The second condition is sigma Y minus YC should be least, that is minimum. That is, beyond that, there is no variations. So like this, you will come across these two conditions, they will play an important role. Where YC is used to designate the trend values to distinguish them from the actual Y values. A is Y's intercept and B is X intercept. Okay, A is the Y-intercept or the computed trend figures of Y variable, whereas when X is equal to 0. B represents the slope of the trend line or the amount of change in Y variable that is associated with a change in 1 unit in X variable. That is the main thing that we consider. When sigma X is equal to 0, then A is nothing but the intercept of Y. You will come across the computed values of Y. Thereby, you can go for a straight line. When you take into account B is nothing but the intercept of X. B is nothing but the intercept of X. And here, you have to take into account, okay, a change in 1 unit in X variable, how it is giving the excuse me, when you come across a change in 1 unit of X, how it gives the Y value. then what is the slope of that? What is the slope of that line? We have to take into account. The x variable in time series analysis represents time. Okay, here you will come across x series. It represents the time. That is year after year, month after month, week after week, hour after hour, like that it will take into account. In order to determine the values of the constants or parameters A and B, we have to use two equations, and we will call them as normal equations. So what are the normal equations that we come across? Sigma y is equal to n into A plus B into sigma x. That is the first equation. The second one is sigma xy is equal to A into sigma x plus B into sigma x square. This is the second normal equation that we come across. And with these two equations, we'll come to know the parameters of A and B. That is the constant values of A and B. When we come across these parameters, automatically, whatever it may be, the value that you are assigning to x, okay, you will come across the value of y. That is, you can be in a position to compute the y values. And after finding out the yc values, computed y values, you have to take into account whether the conditions, two conditions, whatever we are having, sigma y minus yc is equal to 0. And when you will come across this, when x is equal to 0, you will come across the first thing. That is, you can go for the first condition. And the second condition, whatever it may be the y values, from the y values, if you deduct the yc values, the sum of that must be the least. That is, beyond that, there should not be any other value. That is the least and last value that we come across. When n represents the number of years for which data are given, we can measure the variable x from any point of time in origin. But the calculations are very much simplified when the midpoint in time is taken as the origin, because in that case, the negative values in the first half of the series balance out the positive values in the second half, so that x is equal to 0. Okay, you can take any values, because I told you that x variable will represent the time. So you can take any value someone. But when you take into account the middle value, whatever it may be the positive values and whatever it may be the negative values, they will be nullified. Thereby the x will become 0. When x is becoming 0, whatever it may be the first condition that we come across, that is sigma y minus yc is equal to 0, compulsory, you can satisfy. And after that, suppose if x value, if it is not equal to 0, then it may be positive, or x value may be positive, or x value may be negative. When you come across like this, then the second condition, whatever we come across, it will satisfy. That is, sigma y minus yc is equal to the least value. Okay, like this you will come across. In other words, the time variable is measured as a deviation from its mean. Okay, when you want to find out the x values, okay, the x values, you have to take deviation from the assumed mean, from the arithmetic mean, that is measures of central tendency. When you are going for measures of central tendency, you can go for any method, but generally speaking, arithmetic mean and geometric mean only they are useful, because median or mode You can use, you will get the values. But thing is, median and mode are nothing but the positional averages. So when there are positional averages, okay, automatically we may get some values different. But when we go for the calculated values, arithmetic mean, geometric mean, and harmonic mean, okay, most commonly people they'll give preference for arithmetic mean and geometric mean. Okay. Since x is equal to 0, the above two normal equations would take the form of sigma y is equal to NA, sigma xy is equal to bx square. We have to get the x variable values. Depending upon x variable values, you can be in a position to find out the y variable values. That's why they'll take the form of sigma y is equal to n into a. Sigma xy is equal to b into sigma x square. The values of a and b can now be determined easily. Since y is equal to NA, therefore a is equal to y minus sigma y by n, that is equal to bar x, bar y. Since sigma xy is equal to bx square, since sigma xy is equal to bx square, therefore b is equal to sigma xy by sigma x square. Sigma xy by sigma x square. The constant a is simply equal to the mean of y values, and the constant b gives the rate of change. Okay, the rate of change, how much is the change that we come across. With this, we can be in a position to find out the YC values, that is computed y values. Okay, this is about the least squares method. And after that, we are having one more thing, that is nothing but deseasonalized data. What is deseasonalized data? The deseasonalized data is nothing but it is not related to any season. It won't take into account the summer, the winter, the rainy, or any other things. And that's why the word itself, it tells us that it is nothing but deseasonalized data, without giving much importance for seasons. Whatever it may be, the data that we come across, we'll call that thing as deseasonalized data. And why this deseasonalized data? What is the necessity for us to go for this deseasonalized data? You see, some people, they'll move according to the seasons. According to the seasons, they'll move, they'll change, they'll vary. For example, some people of cold-blooded nature, when they come across winter, they cannot stay, they cannot control the winter. So there they will go for hot. That is, there should be some heat for them to heat their body. Suppose when you go for hot-blooded bodies, they can be in a position to control the heat. But whenever they go for a winter season, they cannot control. Winter season, they will control, not see the peculiarity, not heat season, sorry. They will control the winter season, but they cannot control the heat season, because their blood is nothing but a heated blood. Heat bodies. The body is so heat. The body is so heat. And when it is heat, when you come across again in atmosphere heat, they cannot able to control. They'll go for cool atmosphere. They'll prefer to go for cool atmosphere. Similarly, when we go for this opposite thing, cold-blooded bodies, They will always concentrate to take into account the heat atmosphere. They don't prefer to go for cold atmosphere. So deseasonalize data. In all the seasons, you must get the data. When you want to get the data in all the seasons, compulsory you have to go for another thing that is nothing but deseasonalized data. Okay. This means the data which show how things would be or would have been if there were no seasonal fluctuations. See the picture. There should not be any seasonal fluctuations. And even then there are fluctuations. We have to take into account the data. Like that, they'll think. Okay. In order to obtain such data, we have to remove the effect of seasonal variations. The process is very simple. If we are given monthly data, the only thing that is to be done for deseasonalizing is to divide each value by the seasonal index of the appropriate month and multiply the quotient by 100. Hence, to obtain deseasonalized data, divide the actual data by the appropriate seasonal indices. Okay, so this is the thing that you will come across. So with this, the analysis of time series is completed, and in the next class, we are going to take into account an important topic. Until then, have a nice day.